in Switzerland. Scientist Farhang Nabیعی searches for evidence that long-lost planets once roamed our solar system. Farhang studies a fragment of the Alma-Hatasita meteorite, an 88-ton space rock that exploded over the Nubian desert in Sudan. This rare meteorite is thought to have formed in the very early years of the solar system, perhaps even before the Earth itself was born. Tiny gemstones inside the meteorite offer a clue for where the rocks were formed.
These meteorites are from the stony family of meteorites, so they are basically full of rocks. And then one of the peculiar characteristics of them is that they have diamonds. And diamonds, to form, they need high pressure, so they should be really deep inside the planet.
It's impossible for diamonds like these to form inside small asteroids. It takes a rock the size of a planet to create the pressures that are needed. This means the diamonds in Farhang's meteorite were once part of a young planet that got destroyed.
Finding a diamond inside of a meteorite means that that meteorite was once under high temperatures and high pressures, and that could only occur inside of a planetary body.
If this object is then broken up by a catastrophic collision, those diamonds can be incorporated into an asteroid, a small asteroid.
Are these diamonds a relic from a long-lost super-Earth? Farhang looks inside the diamonds themselves to see if there are clues to the size of the planet they came from.
When diamonds are forming, they trap minerals inside, and those things are called inclusions. It's like when you are freezing water, you put a small piece of stone, at the end you have that inside the ice. We want to cut out those diamonds and look at those inclusions and study and see what we can know about this ancient planet.
Different minerals form at different pressures. If Farhang can identify the raw materials trapped inside these diamonds, he'll know the size of the planet they were formed in. The only trouble, the mineral grains are tiny, as fine as a human hair. Luckily, Farhang has access to a multi-million-dollar microscope, one of the most advanced of its kind in the world.
So, this is the transmission electron microscopes. Similar to, let's say, biological microscope, instead of light, it's electrons going through the sample. And here is the sample that we are going to insert inside.
Moments later, the results are in, and they reveal a surprise.
The planet should be at least about Mercury to Mars size to have such a pressure in its interior and form these inclusions and diamonds.
The diamonds are unlikely to have come from something the size of a super-Earth. But could their planet of origin have become part of the rubble pile created by Jupiter?
These meteorites, they have characteristics that shows that it has formed somewhere quite close to Jupiter, but in the inner side of Jupiter, closer to the Sun.
Farhang's incredible analysis proves that our solar system had at least one long-lost planet. We'll have to wait for evidence of the mysterious super-Earths to emerge. But if they did exist, one question still remains. How did the Earth and other rocky planets come to take their place?